All right, let's do problem 25 on page 52 in chapter 2. And here is what's given. Okay, so it says a particle moves along the x-axis. Its position is given by the equation x equals 2 plus 3t minus 4t squared with x in meters and t in seconds. Determine A, its position when it changes direction, and B, its velocity when it returns to the position it had at t equals 0. So I've kind of set up the problem already here. So we're given this position function with time, and we want to know what is the position when it changes direction, and what is its speed when delta x equals 0, but it's on its way, but it's on its way back. Okay. So let's solve it. So let's do A. Well, when it changes direction, so this thing is moving along the x-axis, and at some point it's going to change direction. And when an object moving in one-dimensional motion changes direction, the velocity in that direction, at that instant in time, is 0. Because they have to change direction. Does that make sense? So if something's moving along to the right, it has to stop and, I'm off screen. If it's moving along to the right, it has to stop and then change. So when you're going from this way to this way, your velocity has to equal 0 at that instant in time that you're changing direction. Does that make sense? Okay. So therefore we know that the velocity is going to be equal to 0. Okay, well, let's figure out when the velocity is equal to 0. We have this position function. We also know that velocity is the derivative of position. And when I operate the derivative on this function, we get this. Well, what's the derivative of 2? 0. Plus, and what's the derivative of 3t? 3. And what's the derivative of negative 4t squared?
8. Minus 8t.
Yeah, 2 times 4 is 8, and then 2 minus 1 is 1. Okay? So I'm just applying the power rule for derivatives. So make sure you can do that. And we also know that this has to equal 0. The velocity there is equal to 0. So now we can solve for t. And t to the 1 is just t, so we don't need to do all that. So what I'm going to do is subtract 3 to this side and then divide by 8. So we get t is equal to negative 3 over 8. And this comes out to be over negative 8, thank you. And this is equal to 0.375 seconds. Now, you might want to think about units here. Is that right?
The negative in front, you need to...
Oh, yeah, plus. We're going forward in time here. All right. And let's think about units, though, because they just express it like this. But I'm going to kind of rewrite it just for fun. You didn't even have to do this. But x equals what? This is 2 what? 2 meters. Plus, now what does this 3 have to be?
Meters per second.
Right? Because we want to end up with meters, but I'm multiplying by time. So this is going to be 3 meters per second times time minus, now what is this 4? What units does the 4 have to have?
4 meters per second squared.
Right, because we want to end up with meters, but we have time squared here, so I want to cancel out seconds squared.
You're off screen.
Oh, thank you. Okay. Yeah, maybe I should zoom out. Okay. So, t squared. So I like to add units in here. By the way, be careful. This probably isn't the acceleration. All right. Now, I've got the time when the velocity was 0. So now but that's not what I want to find. I want to know what is the position. So now I'm going to take that time and plug it in. So this is going to be 2 plus 3 times 0.375 seconds minus 4 times 0.375 seconds squared. And when you do the arithmetic for this, you get your answer. X equals 2.56 meters. And please, in physics, do everything in decimals. Don't leave things as a fraction. If you do, I take off 0.1 points because you've annoyed me. Or if you like, minus 1/10 of a point. But if I expressed it like this, I would take 1/10 of a point from my own score. Okay, now part B is a little tricky. What is the velocity when delta x equals 0? Well, look at this. Let's take a look at this position function. This is x equals 2 plus 3t minus 4t squared. But I know that delta x equals, what is delta x? Delta x equals x final minus x initial, right? Well, what is this right here? It doesn't really say. This is actually x naught, right? Or x initial. And this is really x final here. So we need to subtract this to the other side. So I'm going to say that so the delta x is equal to x minus 2, okay? And that's going to be equal to 3t minus 4t squared. So what you had to see here, and this is very tricky, this is why this problem is actually kind of hard, is to get the delta x, the change in position is the final position minus the initial position, and this is the initial position. And then this is equal to 0. See, delta x, x minus 2 is equal to 0. So x must be equal to 2. Okay, but that's not what we want. What we're trying to do here is we're trying to find time. So let's find time. Well, to find the time that this happens, I'm going to divide both sides by time. That cancels this out. Still equal to 0. So I get 3 minus 4t equals 0. So t is equal to negative 3 over 4 over negative 4. So that's 0.75 seconds. Now we did that the sledgehammer way. There's a more subtle way of doing it. Look what we got here. It took 0.375 seconds to change directions. So it's going to take 0.375 seconds to get back to where we started. So what's 0.375 plus 0.375 seconds? If you just doubled the time we got in part A, you get 0.75. Isn't that's kind of cool? And then now I could plug this value in, but what am I trying to find? I'm trying to find the velocity. So the velocity function is, and we already have it here, 3 minus 8 times t. That's equal to 3 minus 8 times 0.75 seconds. And when you do the arithmetic, v equals negative 3 meters per second when you plug all that in. So this is a pretty subtle problem. If you really thoroughly understand how to do this, you're in good shape, because you have to know how to take a derivative, and then you have to know what's true when my velocity is equal to 0, what's true when my change in position is equal to 0, and then plug things in. It's a very, very sophisticated problem. Okay, any questions? That is all.